In this video, we will see the vertical asymptotes of rational functions. First, let's see that a rational function is a function that can be written as the ratio of two polynomials. For example, we can have these three functions, which are ratios of two polynomials. We will be using rational functions that are already reduced to their minimal expression. Let's see our first example. We have the function 1 over x. When we graph a rational function like this one, we get a discontinuous graph. This is a graph of the rational function 1 over x. As the values of x in the negative direction get closer to 0, the value of the function, or the value of f of x, becomes closer to negative infinity. It gets very small very quickly. But if you see the positive values of x, as the values of x get closer to 0, the value of y, or the value of f of x, gets large very quickly, close to infinity. This behavior creates a vertical asymptote. An asymptote is a straight line approached by a curve as one of the variables in the equation of the curve approaches infinity. We can define an asymptote as a line that the graph of a function approaches but never touches. In this example, we can see that the number to which the values approach but never touch is x equals 0, which is the y-axis. Since it is a vertical line in the x value 0, this line can be written as the equation x equals 0. This is the equation of the vertical asymptote of this function. Let's see another example. Now we have the rational function x over x minus 2. This is the graph of the function. If we trace a vertical line here, in the value that the curves approach but never touch, we are tracing the vertical asymptote. And we can determine the equation of this vertical asymptote because the value of x that we just graphed is x equals 2. So the equation of the vertical asymptote of this function is x equals 2. But how can we determine the value of the vertical asymptote without graphing? It is actually very simple. What we have to do is to find the value of x that makes the denominator become 0. In this example, the denominator is x minus 2. So to find the asymptote, we equalize x minus 2 equals 0, and then clear x equals 2. This is the vertical asymptote of the function. To understand the logic of this, remember that we can't divide over 0. That means that the denominator of the function can have any value except the one that makes the denominator as 0, because that value does not exist for the function. In this example, when x equals 0, what do we get? F of 2 equals 2 over 2 minus 2. That equals 2 over 0. And 2 over 0 is indeterminate. It doesn't exist. That's why in the graph you see that the curves never pass through the line x equals 2. You can probably tell just by watching this graph that there is also an horizontal asymptote. It's here. But we will cover that in another video. Right now, we will only be working with vertical asymptotes. It is also very important that you know that in some rational functions, there can be more than one value of x that can make the denominator equal to 0. Let's see an example where that happens. Let's determine the vertical asymptote of the rational function f of x equals 2x over x squared minus 4. First, we equalize to 0 the denominator. The denominator is x squared minus 4, and we equalize to 0. Then we clear the x squared equals 0 plus 4. X squared equals 4. x equals the square root of 4. And here we get two values of x. One of them is x equals 2, and the other one is x equals minus 2. That means that this function has two asymptotes. Let's see the graph of the function. Do you see the two asymptotes? They are here. You can clearly see that the asymptotes are in x equals 2 and in x equals minus 2. Now you know that to find the vertical asymptote of a rational function, you look for the values of x that make the denominator become 0. In the next video, we will see how to find the horizontal asymptotes of rational functions. Thank you for watching this video.